So, it is 10:13, right? 10, 13, 21. So our objective is really going to be graphing polynomials. Polynomials are curvy. And we've seen these. Last week, I think we talked about them. We actually looked at pictures of them, right? We talked about how they're like, they could be curvy like this, or sometimes they can be curvy like this. And the bigger the degree, the more curvature we have, okay? So one thing we can do is, just like we did yesterday, we can factor and find the zeros first. We're going to find the zeros, we're going to take this and set it equal to 0, okay? So to find the zeros, we set it equal to 0. So all right, I'm going to go 0 equals x cubed minus 9x, okay? So if you don't show your work on Friday's test, you're going to lose a point. Okay? So what I'm going to do first, if it says factor, what I notice is that they both have a common x, don't they? So I'm going to common factor out an x. That's what I notice. Hopefully you guys notice that too. They both have an x in common. I like to common factor because it makes the problem easier. If you can common factor, I like to do that because it makes the problem easier. That leaves me with an x squared minus 9. Hopefully you know there has to be 3 answers, right? There has to be 3 answers. So if I factor this again, I'm going to get 3 equations. X and x. So if I have 3 mini equations, I'll get 3 answers. I'll go plus 3, minus 3, okay? Well, we're not done because I want the zeros, so I've got my mini equations, right? So I'll have a 0 equals an x. I'll have a 0 equals an x plus 3. Now the 0 equals an x minus 3, okay? And then I'll just solve. Well, solving is going to be pretty easy in this case. X equals 0, that's done, right? Minus 3, x equals negative 3. Again, we're in Algebra 2. I shouldn't have to solve that, right? Plus 3. These are zeros. So what zeros are lines on the x-axis, okay? So this is like a point 0, 0, a point negative 3, 0, and like a point 3, 0, okay? So these are my zeros. So I'm going to put those on my graph. 0, 0, negative 3, 0, and I'm going to get a point at 3, 0. Now, graph this polynomial. It says graph it. So how are we going to graph it? Let's use our Desmos. Okay, let's let our technology do this. Okay, so we go to our phone, and we're going to use Desmos. Okay, let's check it out. Let's see, where's my phone? My phone's around here somewhere. Well, where's my phone? Oh, it's right in front of me. I'm so silly. There it is. All right. So I'm going to graph just my equation, right? So I'm going to go graph. Everybody at Desmos? Am I going too fast? Everybody have Desmos out? So we go y equals, right? Y equals, and I'm going to go x to the 3rd power. And then I'm going to go minus or subtract 9x. All right, I'm going to get mine to look better. There's a better picture of it. You guys okay with that? There's my better picture, okay? So it says using Desmos, find the local max and local minimum. Well, Desmos is so cool. All I do is tap on it. That's got to be, you guys agree that's my max? There's my max. I just tapped on it. Right? I just found it, tapped on that. So my local max is at, I'm going to round to the nearest tenth, a negative 1.7, comma, 10.4. My local min, that's easy. It's right there. Just tap on it. So my local min is at a 1.7, comma, negative 10.4. Okay, how am I doing? Let's see. I don't know if this is going to fit. Maybe 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's going to be a little bit off my paper. That's okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's going to be a little bit off my paper, but I can live with it. I can live with that. It doesn't have to be perfect. So I'm going to graph these points. Let's put these points on my graph. All right, that's not too hard. I'm just going to go estimate negative 1.7 and go up 10.4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.4. About there. It doesn't have to be perfect, but about there. And I'll graph this point, right? So this point, I'll graph at 1.7 and negative 10.4. So I'll go, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.4. About there, okay? How am I doing? Now I know what it looks like because I just put it on my calculator, right? I let Desmos. So I know it looks like this, okay? So it goes. Okay, can you do this on the test on Monday? I mean on Friday. So you're going to be able to use your phones on Friday to do the very first question. And once you get done with the very first question, you put your phone away and you'll get to do the rest of the test. That seems like a better way, doesn't it?
Yeah.
Hello? Yes. I'll send her down. Okay? Bye-bye. Adios, amiga.
Bye.
The office. I think somebody's here to pick you up. Okay, now, how am I doing so far? How am I doing? Okay, okay? Okay, you guys, everybody good? Thumbs up on that? Thumbs up? I got my picture. I got my max by tapping it. I got my min. Okay, now, describe the intervals of x where the polynomials increase and decrease. So here's what I want you to do. Okay, please do this. Kids mess this up, but you're not going to. So what I want you to do is this. Draw a number line. Draw a number line. Bye, have a great day. Draw a number line. Okay? And this is my x-axis, okay? Draw a number line. And this is my x-axis, okay? So what we're going to do is we're looking at the x-axis, which is here, okay? We're looking at our x-axis. And my number line, of course, has a, 1, a 2, 3, 4. A negative 1, a negative 2, a negative 3, negative 4, blah, blah, blah. Okay, everybody have a number line? Okay. This gets really easy if you use the number line. Okay. So it is going. So we read from left to right. Okay, it's agreed. We're going uphill here. You agree with that? Somebody goes, no, Mr. You're going down here. But no, we don't go that way. We go from this direction, right? So we're going uphill until we get to that point, right? Yeah. What is that point? What's that point right there? No. Okay, it's a negative 1.7, right? But the x-axis, right? So we're going to put the x values, okay? So put that point on your graph. So put that graph on my point. Negative 1.7, right? And it's going downhill, right? It's going downhill until right there, right? And so what's that value? Positive 1.7, right? So we want the x values. X values. So right there, positive 1.7. We'll put a dot. Yeah, but at 0, it's still going down, right? Totally agree with you, okay? And then it's going uphill from there, right? So here's what I want to write. it's going uphill here, isn't it? From negative infinity to negative 1.7 is going uphill. You guys agree with that? And then from negative 1.7 to positive 1.7 is going down. You guys agree with that? And then from 1.7 to infinity, it's going up. Okay? So I heard Braden say it. It's just the x-axis. Okay? I heard Braden say it, you said it, right? It's just the x-axis. So if you look at just the x-axis, it's going uphill until you get to negative 1.7. And then it's going downhill from negative 1.7 to 1.7, right? And then from 1.7 to infinity, it's going uphill again, okay? So it talks about intervals of increasing and decreasing. So we're going to write this. We're going to write what we just put, okay? So I'm going to write increasing. I'm going to say from, look, up. It says up, right? From negative infinity to 1.7. Because it says up. So I'm going to say from negative infinity to negative 1.7. Where else is it going up? Where else is it going uphill?
From 1.7.
Yeah, also from, so it goes uphill in two different places. From 1.7 to infinity. Awesome. That's easy.
Yep.
Now, what about decreasing? When's it going downhill?
From negative 3 to 1.
From a negative 1.7 to a positive 1.7. So if you make the number line, and remember what Braden said, the number line is the x-axis, so only the x values. And if you put your up, down, up, then writing this gets easier. You okay with that? Now, end behavior. End behavior, okay? Oh, sorry. Okay. End behavior, I want to show you this, okay? I want you to do this. I want you to take two fingers, put one finger here, one finger here, okay? I want you to do this. Put your fingers here, okay? Everybody do this. Physical, put it right on your graph. Put it right there on your graph, okay? No, put it on your paper. Put your fingers on your paper. On your paper. Paper on your paper, okay? Now watch. As x gets bigger, y goes bigger. Do you see that? On this graph, as x gets bigger, y gets bigger. Do you agree with that?
Yes.
So end behavior is as x goes to infinity, where's y going?
X goes up while
Yeah, it's easy, isn't it?
Y goes
End behavior.
up while Y goes out.
So end behavior,
But they both go out their own way.
end behavior, we're going to say as x approaches infinity, y approaches infinity, okay? That's end behavior, because you're going to infinity. And as x approaches negative infinity,
Y goes negative.
yeah, y is going down to negative. It's that easy. Y goes to negative infinity. Can you do that on the test?
So could we just
Probably
say,
can.
You need to put both. Because there's two places x can go. To positive infinity and to negative infinity. Is if x goes to positive infinity, what's y doing? Positive infinity, right? If x is going to negative infinity, where's y going? Now, if the graph was upside down, it'd be the opposite, right? Okay. All right, ready to the page? Okay, ready to the page? Okay. Now, example 2. Well, I've got some equation, y equals, and it has an x minus 3. It's got an x plus 2, and it has an x plus 4 because those are its roots or 0, same thing, okay? Now, one more time. I have an equation. Let's do things backwards. I know if I did my mini equations with me, mini equations, solve, I'd get 3. You agree with that? If I do my mini equations from here, I get negative 2, right? If I do my mini equations from here, I get negative 4. So all we're doing is working it backwards, okay? So we made the equation that makes our answer. Everybody good with that? Now, there is some value, we call it A, that makes this thing go through the point 0, 4. So what we're going to do is find a. Well, all right, we can do that. We can do that. We've done this before. We have done this before. That is an x value, and that's a y value. Every point has an x and a y, right? So what I'm going to do is put my 4 right there. Put my 4 for y, and put my 0 here for x, 0 here for x, and 0 here for x, okay? All right, so I'm going to go 4, because that's my y. I want to find a, so I'm going to go a. X is 0, minus 3. X is 0 plus 2. X is 0 plus 4. Okay, right? Now see what I got. So I've got 4 equals. All right, I can simplify this. So I plugged 4 for my y value, 0 for my x's, and now I'm going to simplify. All right, that's negative 3. 0 minus 3, that's a 2. That's a 4, right? Let's see, that is 24. 3 times 2 times 4 is 24. But it's a negative 24, right? We've done this before. You guys remember doing this before? Divide by negative 24. And if I reduce, I get negative 1/6 for the value of a. So now I've got the equation. I'm going to put that right there. And I'm going to rewrite this as y equals a negative 1/6. I'm going to go an x minus 3, x plus 2, x plus 4. And that's all I have to do. We've done this before with much easier equations. We did this in chapter 2. Okay, last problem. And this one's going to be easy because we already graphed this one, didn't we? We already graphed it. So I'm going to go back and I'm going to regraph it. It looks like this. And I'm going to go 1.7 and 10.4, about there, about there. It's not going to be perfect, but I'm not worried about it because I want to just move it. Okay, not perfect, okay? Now let's move it. We're going to move it to the left 5. And 2, oh, we're going to go 2 to the left, my bad, and 5 up. So we're going to go 2 to the left, and we're going to go up 5. All right, I'm going to take this point. That'd be the easiest point to move, right? 2, and then 1, 2, 3, 4, 5. That's my middle point. So it should look something like... Now, if I had the equation, it'd be a lot easier to graph on decimals. You agree with that? So the equation is going to be this. G of x equals x plus 2 cubed minus 9 times x plus 2 plus 5. Now, what the heck did I do? I'm going to show you, because you know this. Okay, we do this, okay? Okay, don't fall asleep on me, Angel, because I'm going to do the dance. I'm going to do the dance. Hey, you! I'm going to dance, but I'm inside the parentheses, right? Remember the dance? I'm inside the parentheses. And when I move this way, inside, I'm going the opposite direction, right? So when I said I wanted to go to the left, instead of minus 2, I went plus 2. Remember that?
Yeah.
Okay, and then I just went up 5. And that's my new equation. Okay. All right, that is what I have, including a homework assignment for you. I know these short periods are tough to get everything in, but we did a great job. Okay, let me go ahead and stop the film.